In this video by the Aggie Math Learning Center, we will be covering how to perform partial fraction decomposition. We will work through 3 problems and discuss some key concepts as we work through them. The first problem gives us the following: x to the 4th plus x to the 3rd minus 20x squared plus 18 divided by x squared plus x minus 20. We are asked to perform partial fraction decomposition. Pause the video and give the problem a try. The first thing you want to be looking for in these problems is whether or not the degree of the polynomial in the numerator is less than the degree of the polynomial in the denominator. If this isn't the case, then partial fraction decomposition cannot occur yet. In this problem, we see that there is an x to the 4th in the numerator and an x squared in the denominator. Because the degree is higher in the numerator, we will need to use a long division to pull out a common factor. Let's do that. We will set it up like x to the 4th plus x to the 3rd minus 20x squared plus 18 divided by x squared plus x minus 20. We see that in order to get our divisor to go into x to the 4th, we will need to multiply it by x squared. So we put that on top of the line. We will then write out what we get when we multiply the divisor by x squared. We will subtract this from our dividend to give us 18 as our remainder. From this we know that we can pull out x squared from the fraction, which will give us the following new expression: x squared plus 18 divided by x squared plus x minus 20. Now we have a numerator with a lower degree than the denominator and can proceed with partial fraction decomposition. The first step of partial fraction decomposition is to look and see if we can factor the denominator. I won't go into how to factor polynomials in this video. Looking at x squared plus x minus 20, we see that it can factor into x plus 5 and x minus 4. What partial fraction decomposition does is take the complex fraction and break it into simpler fractions that are added together. For example, we will be breaking the fraction 18 divided by x squared plus x minus 20 into a divided by x minus 4 plus b divided by x plus 5, where a and b are values that we will need to solve for. We can solve for a and b by some algebraic manipulation. We can multiply both sides of our equation by x squared plus x minus 20, which will give us 18 equals a times x plus 5 plus b times x minus 4. Notice that multiplying by x squared plus x minus 20 is the same thing as multiplying by x plus 4 times x minus 4, which is why we see the x minus 4 cancel out in the a term and the x plus 5 cancel out in the b term. From there we can distribute the a and b to get 18 equals ax plus bx plus 5a minus 4b. Next we will create a system of equations to figure out what a and b are. Notice that if we combine the two x terms, we get a plus bx, and that there are no x's on the other side of the equation. Therefore, we can say that a plus b equals 0. Additionally, we see that 5a minus 4b is just a term for a number, and that the number on the other side of the equation is 18. Therefore, we can say that 5a minus 4b equals 18. Now, we have 2 equations and 2 unknowns, meaning that we can solve this system of equations. We will use the substitution method to solve these equations. Using a plus b equals 0, we can say that b equals negative a. We can then plug in negative a for wherever b is in the second equation. This will give us 5a plus 4a equals 18, which can be simplified to 9a equals 18. Dividing both sides by 9 gives us a equals 2. We can then plug this into our first equation, solve for b, which tells us b equals negative 2. For our solution, we will need to plug in these values for a and b to give us x squared plus 2 divided by x minus 4 minus 2 divided by x plus 5. Now that we have covered some basic techniques for partial fraction decomposition, we are going to work through an example that has repeated factors. We are given x plus 3 divided by x squared minus 4x plus 4, and are asked to use partial fraction decomposition to rewrite it. Pause and try to work out this problem on your own. The first thing we want to do is make sure that the degree of the polynomial in the numerator is smaller than the degree of the polynomial in the denominator. we see that the numerator has x and the denominator has x squared. So we are good to proceed with partial fraction decomposition. Next, we want to factor the denominator. We see that x squared minus 4x plus 4 factors into x minus 2 and x minus 2. When you see that there are two or more roots that are the same, we call this a repeating root. When you have a repeating root in the partial fraction decomposition, you will see the breakdown from x plus 3 divided by x squared minus 4x plus 4 look like a divided by x minus 2 plus b divided by x minus 2 squared, where the denominator is squared for the second fraction. If you're wondering what it would look like for the same root to be repeated 3 times, we would see another fraction that would have the root to the third power in the denominator. We can then follow the same technique as the first problem to solve for a and b. We will multiply both sides of the equation by x squared minus 4x plus 4, such that we have x plus 3 equals a times x minus 2 plus b. After distributing the a, we have x plus 3 equals ax minus 2a plus b. We then see that there is 1x on the left side of the equation and ax is on the right side. Therefore, a must be 1. We also see that there is 3 on the left side, and our number term on the right side is negative 2a plus b. Since a equals 1, we know that 3 equals negative 2 plus b. Therefore, b will be 5. We can plug in our a and b values into the partial fraction decomposition to give us 1 divided by x minus 2 plus 5 divided by x minus 2 squared. This is our solution. We'll go over one final type of partial fraction decomposition that contains irreducible factors. The problem we are given is x minus 3 divided by x to the third minus x squared plus x minus 1. And we are asked to use partial fraction decomposition to rewrite it. First, we look at to see if the degree of the polynomial in the numerator is smaller than the degree of the polynomial in the denominator, and that is correct. Next, we will look to factor the denominator. We see that x to the third minus x squared plus x minus 1 will factor into x minus 1 and x squared plus 1. X squared plus 1 is considered an irreducible factor, since it cannot be factored any further without getting imaginary numbers. When you have an irreducible factor in partial fraction decomposition, we need to look at the degree of that factor. In this case, it would be 2, since there is an x squared. The numerator of this partial fraction will look different than what we have worked with in order to compensate for the irreducible factor. In this case, since the factor had a degree of 2, our numerator needs to have a degree of 1. Therefore, we will rewrite this factor as ax plus b divided by x squared plus 1. Putting this together with our other factor, our breakdown is x minus 3 divided by x to the third minus x squared plus x minus 1 will be ax plus b divided by x squared plus 1 plus c divided by x minus 1. Now all we need to do is find what the variables a, b, and c are. We do this by multiplying both sides by x to the third minus x squared plus x minus 1, which gives us x minus 3 equals ax plus b times x minus 1 plus c times x squared plus 1. We then distribute what we can to get x minus 3 equals ax squared minus ax plus bx minus b plus cx squared plus c. We then see that there are 0 x squares on the left side and a plus c x squareds on the right side, meaning 0 equals a plus c. We also know that there is 1x on the left and b minus a x's on the right, giving us 1 equals b minus a. There is also a negative 3 on the left side and c minus b on the right, giving us the equation negative 3 equals c minus b. We now have 3 equations and 3 unknowns, allowing us to solve the system of equations. In the first equation, we can say that a equals negative c. If we plug in negative c for a in the second equation, we will get 1 equals b plus c. After solving for c, we see c equals 1 minus b. We can then substitute 1 minus b in for c in the third equation to give us negative 3 equals 1 minus b minus b. After solving for b, we see that b equals 2. We can then use this to solve for a in the second equation. When we plug in 2 for b, we get 1 equals 2 minus a. This means that a equals 1. Now we can solve for c with that first equation, which tells us c equals negative 1. With those variables solved for, we can write our final solution as x plus 2 divided by x squared plus 1 minus 1 divided by x minus 1. If these or any other concepts require some more of your attention, feel free to watch this video again, reach out to your professor or recitation leader, or utilize the free tutoring services offered at the Aggie Math Learning Center. We hope this video has been helpful.